Hello and welcome. I'm Dr. Pauline Fu. In this lecture, I will present examples and exercise about multiple regression. So first, example 4.1. A collector of antique grandfather clocks sold at auction believes that the price received for the clocks depend on both the age of the clocks and the number of bidders at the auction. Thus, he hypothesized the first order model y equal to beta 0 plus beta 1 times x1 plus beta 2 times x2 and plus epsilon. Epsilon is the random error. Okay, so I'm going to, it is just epsilon without this y. A sample of 32 auction pieces of grandfather clocks along with their age and the number of bidders is given. Question 1, use scantograms to plot the same data. Interpret the plots. 2, use the method of least squares to estimate the unknown parameters beta 0, beta 1, beta 2 of the model. Question 3, found the value of SSE that is minimized by the least squares method. Okay. So the data file is GF clocks. It can be found on D2L under course materials, then data. Okay. So I'm going to use SPSS to do it. So I will open SPSS. So this is my another file. It is actually, I'm going to reopen the file. So I will click maybe file new. I will go to the new data. So this is a new data set. So I'm going to click file, open, or import data, because the data is in Excel file. The data file I put on the D2L is a CSV file. After you open the CSV file, you can save it in Excel file. Okay, so I'm going to click the Excel file, import Excel file, and this is the Excel file I saved. Okay, grandfather clocks, and I click open, and then click OK button. Okay, so this is this data file. I try to manage the screen so that you can also see the questions here. Okay, so this is the question, okay, on this part. So first I'm going to, this is the data view. The number of bits, I want to change it to numerical data, okay, scale. So I'm going to go to data view. If you don't change it, it is still fine. So I'm going to go to variable view, and then from the manual, SPSL accept 3 types of data. One is nominal with this 3 circle. The other is ordinal with this little bar. The last one is scale. Scale has the highest level. So I try to use the scale and then go to data view. So it becomes scale. And I also want to label which one is X, which one is Y. Here, Y is auction price. Okay, so I'm going to go to variable view. So price is Y. So I will add maybe underscore Y. And I have 2X because this is multiple regressions. X1 is the age of a clock in years. Age of the clock, that is my X1. And then number of bidders, this is my X2. Okay, And then I go to data view. So it is clear, this is Y, this is X1, and this is X2, okay? And how many sample data in this data set? Total 31, 32. You see 32. It's not like Excel, the heading does not count as raw. Okay, so total 32 data. Okay, 32 samples. All right, so what is the question here? Question asks you, use the scatter plot to plot the data. Because I have two X, X1, X2, so I'm going to plot two scatter plot. One is Y versus X1, the other is Y versus X2. Okay, so I will go to graphs, legacy diagrams, and then scatter plot. I just choose the simple scatter plot and quick define. So now what is my Y? So price is Y, X, age is my X1, okay? And then I'll click OK button. So this is the plot. Okay, so this is the plot. So I'm going to copy this one just for future reference. I'm going to copy this one, copy screen. And paste it somewhere here, maybe. Oops. So that is the scatter plot, okay? And then do the same thing for price versus X2. Create a scatter plot. So basically you just repeat yourself, okay? Scatter plot. Y is still price, but X, I will move it over to X2. And then click OK button. Okay. So this is X2 versus Y, or Y versus X2. Okay. So again, I will copy this and paste it below. I want to paste it here. Just try to go back. Why I can't go back? I just have to maybe wait. I need to go to this page, module 4. Okay. So I'm going to undo it. And I want to paste it here. Okay. As you can see, from the output, looks like when you age increase, the price also increase. Okay, there seems to be has a linear relationship between price and age. And for the next one, number of bits, price and the number of bits, also there's a relationship between Y and X2. But that relationship is not as strong as the first one, the price versus X1. Okay, so I answered the first question. Create a scatter plot. Okay, create a scatter plot. Now, second question. Fit the model of least squares to estimate beta 0, beta 1, and beta 2 of the model. So remember, what is the model? This is the model. So in this model, our task to estimate what is beta 0, beta 1, beta 2. Okay, so to do that, we use, again, SPSS. Okay. So I'm going to, so that is the question. Analyze regression linear. And now dependent is Y. Independent, I have two. One is H, the other is X2. You press Control to select both of them and move them over. Okay. After that, anything else I need to do? That's it. Click OK button. And then you have this ANOVA table. Okay, ANOVA table will tell you if the model is significant or not. Okay, so you look at the p-value. The sig value is the p-value. P-value smaller than alpha. Alpha usually 0.05. So when p-value smaller than alpha, the model is significant. Okay, and on coefficients table, you have the constant. This constant is beta 0, and this 12.741 is beta 1, and 85.953 is beta 2. So we get those parameter estimate. Beta 0 is negative 1338, beta 1 12.74, beta 2 85.95. Okay, so I just copy this on my OneNote. Okay. Maybe over here. So based on, so we answered question 2, estimate beta 0, beta 1. Okay, so I will just add a notation. So this is a, try to use this. Okay, so this is beta 0, negative 1338, and beta 1, 12.74, and beta 2. Okay, once you have this value, you can say the model is Y equal to negative 1338. If I omit decimal, maybe I will put just keep 2 decimal place, 0.95, and then plus 12.74 x1, okay, and then plus 85.95 x2, and plus random error epsilon. So this is the model. This is the model. Okay. All right, so that answered the question 2. Okay, question 2. Let me go back to my OneNote. Question 2. And question 3, found the value of SSE. Okay, that is minimized by the least square method. So found the value of SSE. Again, you go to the output. Here, SSE. This number is SSE, 516726. Say sum of square due to error, SSE. Okay, so I'm going to try to use my mouse use my mouse, and then so just want to make a notation for SSE. Graph here. Okay. So this number is SSE. Okay. This is S sum of square due to error. Okay. All right, so this is a multiple linear regression example. We set up a model with two independent variables, x1 and x2. Okay. So next question, we are going to use the same data set, grandfather's clock, and then we are going to do different questions. Okay, here. This one, we are asked to do, it is the same data set, the same model. Okay, there's a redundancy here. Let me, this one is redundancy here. Let me delete this one. Okay. So it is still the same model, but the question, three different questions. Question one, estimate the average auction price, okay, for all 150 old clocks sold at auctions with 9 bidders using 95% confidence interval. Okay, so this is average. Okay, and then predict auction price for 150 years old sold at an auction with, again, this is 9 bidders using 95% prediction interval. So one is confidence interval, okay, confidence interval, and the other is prediction interval. So those are the two questions, okay? So I'm going to pull out my data. So to answer those questions, okay, confidence interval, prediction interval. Okay. So how do I do that? You do this, analyze regression linear. So Y independent variable is price Y, X1, X2 is independent variable. And then you click save button. This is the key, click save. And then you check out mean prediction interval for mean and for individual. Use 95% confidence interval. Okay, and then you click OK button. Click OK. Okay, it will give you the same result, but this time when you go back to data, see, you saved your result here. Okay, this is a LMCI lower bound for average mean confidence interval. M stands for mean. Okay, so this is lower bound for mean. This is upper bound for mean, and this one here, LICI, lower bound individual confidence interval. Okay? And this UICI, upper bound individual confidence interval. Okay, and now let's locate the number here. See, the question asks you, what is the mean and the individual confidence interval when the age is 150, the number of bits is 9. So those are the answers. Okay, so I will just copy this screen. Okay. and paste it here. And then I will move my mouse to make annotation. Okay. All right, so I'm going to make annotation. So this is the answer for question A. What is the mean prediction interval when you have age 150, number of bits 9? And this is the answer for question B, question 2. What is individual confidence interval when you have age 150 and number of bits 9? Okay, so that is the answer for question 1, and this is answer for question 2. Okay. All right, so go back to the third question. Try to adjust my computer. No. I want to go back. This one like annoying. So I'm going to move this over. And then I focus on no. Try to move my, okay, here we go. Here I go. Try to show you the questions. We answered the first 2 questions. And there is a third question here. Okay, this is the third question. Suppose you want to predict the auction price for one clock that is 50 years old and has 2 bidders. How would you proceed? How would you proceed? To answer this question, you have to go back to look at the original data. Okay. The question asks you to predict the price when the age is 50, number of bids is 2. Okay. Go this original data, you can see the minimum age might, it is at least 100 years old, right? We don't have 2 digits. All the age are 3 digits. Okay, so if I go up, see, all the age are at least 100 years old. Okay, and you are asking me to predict the age is 50 years old. So this 50 is outside my data range. So I cannot make a prediction. Okay, and next, let's check the bidders, number of bidders. Number of bidders here, you asked me to say 2 bidders. The smallest bidders in this data is like maybe 6. 6 is the smallest number. Okay, and 2 is outside the boundary of original data. So I cannot make prediction. Okay, if you really want to make prediction, you have to collect more data. Right now, I only have 32 data. You have to collect more data, okay, to make sure the original data has this range, 50 and 2. Okay, so that is the answer for question 3. We cannot make prediction because 50 and 2 are outside of original data range, far away from original data, average data. Okay, so that is this question. Right. Not sure I clicked the recording button. Yes, I clicked the recording button. Okay, next question. Next question. Black Friday. The International Journal of Retail and Distribution Management published a study of shopping on Black Friday. Researchers conducted interviews with a sample of 38 women shopping on Black Friday to gauge their shopping habits. Two of the variables mentioned for each shopper were age is X, number of years shopping on Black Friday is Y. Okay. So we have Y, we have X. What is the question here? The question asks you to fit the quadratic model. This is the quadratic model. EY equal to beta 0 plus beta 1 X plus beta 2, then X squared. X squared, okay. I'm going to use SPSS, okay. And to conduct a test on overall adequacy of the model, use 0.01. Okay. So first, let me pull out the data in SPSS. So this is a blank data sheet. I'm going to import data. I already saved it in my computer. It is, say, Black Friday data. Okay. So I click open. So this is the original data. Again, age. So what is X, what is Y? Let me see. Age is X, okay. Number of years is Y. Number of years is Y. So I'm going to change the variable name so that it is clear what is X, what is Y. So I'll go to variable view. So age is X. Oops. Age is X. Yes is Y. Okay. And there, yes, scale variable. Then I go to data view. So age is X, Y is yes. Okay. So what is the question here? The question asks you to create a quadratic model. Quadratic model. So how do I create quadratic model? You go to Analyze, Regression, Curve Estimation. And now, number of years is Y. Initially, it is here because I did this before this recording. So what is dependent variable? Y is dependent variable, yes. Independent variable is X, age is independent variable. Now I want quadratic, so make sure you check out quadratic, okay? If you want other models, for example, logistic, you can select here. If you want logarithm, you can select here. But right now, I only want quadratic model. Okay, and I also want the ANOVA table. So I check out ANOVA table, and then click OK button. So now this is the output. Okay, so number of years and age. I have ANOVA table. I'm going to copy this into my OneNote so that I can make annotation, okay? So what do I need? Model summary, yes, model summary here. Okay, so I'm going to create print, and then I go to my OneNote and copy this. Maybe I will copy here. No, maybe here. Okay. So what is the question here? The question asked me to write down an equation, quadratic equation, okay? So see, I have a constant, I have x, I have x squared. So the model would be, oops, y equal to, initially the model is beta 0 plus beta 1 x plus beta 2 x squared. This is quadratic model, okay? So now I know I estimated beta 0, beta 1, beta 2 here. So this one is beta 0 constant, and this is beta 1, the coefficient in front of x, and this is beta 2. You just plug in those numbers into the equation. So the equation, the model would becomes negative 8.933 beta 1 is 0.704 x, beta 2 negative 0.003, and then x squared. Okay, this is my quadratic equation, okay, quadratic model. And then the question also asks you if this model is significant. How do I know? You go to the ANOVA table to check out the p-value. The sig value is the p-value, okay? This p-value is 0, smaller than alpha. When p-value is smaller than alpha, the model is significant, okay? The model is significant, means the model is appropriate. And we can use this model to make prediction, okay? So that is a quadratic model, okay? In summary, I did one example and one exercise to illustrate multiple regression model. Thank you so much for your time. I look forward to see you next time.